Hello everyone, welcome to the KVF Physics Academy. Today we are going to the study of the beta decay, and we know that beta decay is relative to radioactive nature. Yes or no? We know that in a general case, or before of this lecture, we can study the gamma decay as well as alpha decay. Yes or no? This is also related to the radioactive nature. Yes or no? Now, here is how we consider the beta decay. Beta decay are present inside the nucleus. Okay. Suppose this electron shifted to inner radius or inner shell. Then what happened? Photon is emitted. Yes or no? Means here we know that inside the nucleus proton and neutron is present, but outside the nucleus electron are present. But we know that the beta nature means electron. Beta nature means electron. We know that beta minus means electron. Minus 1 is 0. Beta plus nature means a positron. Beta plus means there is plus 1 e to the power 0. Yes or no? Means this beta decay is related with electron. But we know that inside no any one electron is present. Yes or no? All electron outer the nucleus. Then how this electron is generated inside the nucleus? This is a very important question. How this electron is generated inside the nucleus? Yes or no? Means न्यूक्लियस में तो कोई इलेक्ट्रॉन होने का चांस होता ही नहीं. जो भी हमारे इलेक्ट्रॉन्स रहेंगे all revolving around the nucleus. Yes or no? No any one electron are present inside the nucleus. Then how this electron is generated inside the nucleus? Yes or no? Now, see here. We know that Eco has said that continuously proton is converted into neutron and neutron is converted into proton. This process is a continuous process. Yes or no? But here pi meson are involved in this case. Yes or no? Means the proton is converted into neutron with the pi plus proton is converted into neutron. Pi plus neutron is converted into proton, pi minus. Okay, and proton to proton conversion with a pi 0. Okay, this nature. This here is no emitting of any particles. Yes or no? But this here is a radioactivity. This atom is tend to stabilize. Yes or no? Stabilize. Hence, some amount of loss will be take place. Yes or no? Beta here. This also one type of loss. Alpha also loss. Gamma also loss in an atom. Okay. Now, beta. Decay, loss. Now we know that here we can study it beta plus decay, beta minus decay, and as electron capturing. This 3 point is important. Electron capturing. Okay. Now studied one by one. We know that inside neutron is converted into proton. Proton is converted into neutron with increasing atomic number 1, but mass number will be same. Yes or no? What is the general reaction for this case? Suppose this one is X atom. How to write down this one? ZXA. Okay. Now suppose we consider here is a beta minus decay. Okay. Beta minus decay. Means which particle is emitted? Minus 1 e to the power. What is the mass of electron? The mass of the electron is equal to 0. Mass of the electron is equal to how much? 0. Or we know that here in a beta minus, here reduced by 1. Z is reduced by 1. Okay, means here proton is converted into the neutron. Minus 1. Okay. And here this atom, whatever this atom, having mass will be same. A is same. Okay. Means here we can take the minus 1. We know that. Charge also conserved. Yes or no? Law of conservation of the charge. Means here we can take Z plus 1. Means here one neutron is converted into the form of proton. Z plus 1. Means here is a mass also we need to conserve. Means here we can take the 0. Here we can write on the 0. Here A is equal to A is equal to 0 means here we need to take 0. Here is a Z. Here is a Z plus 1. Here also we need to conserve this quantity. Means here we can take the minus 1. Then which particle have minus charge? Minus charge and mass is equal to 0. Mass is equal to 0. This particle is known as electron. This particle is known as a electron. Yes or no? Electron or a beta minus particle or beta minus particle. Got it? Beta minus next. Plus some amount of Q amount of energy will be emitted in this case. Q amount of energy will be emitted in this case. Next one. Z, Xa, beta. Now we consider the plus. Beta plus. This particle decay into beta plus means here a plus 1 charge particle is emitted. Here is a plus 1 means we need to subtract 1 charge from this atom. And Y atom having the atomic number is equal to Z minus 1. Mass number is A. Again we need to conserve this mass. Means here is a here also A. Means here we need to write down 0. This is known as a 0. Okay. Now here is Z minus 1 plus 1 conserved, and this particle is known as a positron. This is known as a positron, and some Q amount of energy will be emitted in this case. Some amount of energy means how much amount of energy is emitted here? Q amount of energy will be emitted here. Got it? Next, this is a beta minus a beta plus. Beta minus beta plus. Now, electron capturing. Consider next. Beta plus beta minus. Beta minus beta plus. Beta plus. Okay. Means here proton is converted to neutron. Neutron is converted into proton. Means here inside become a Z plus 1. Means we know that a neutron have charge 0 and mass is 1. Neutron have this charge is 0 and mass is 1. It's converted into, here atomic number is increased by 1. Atomic number is increased by 1. Okay. Mass number is 1. Mass number is 1. Again we need to conserve this quantity. Yes or no? Here mass is conserved. Mass is conserved. Next we need to conserve charge also. Okay. Means here we need to pick the minus 1 charge. Minus 1 charge. Mass already conserved. Mass already conserved. Hence we can take here is a 0. Then and then only this system will be conserved. What is this particle? Particle is known as a beta minus or electron, or some amount of Q amount of energy will be created in this process. This is known as a beta minus decay. Beta minus decay, neutron is converted in the form of proton. Neutron is converted in the form of proton with emitting one electron. Emitting with electron. Okay. This one is a beta minus decay. Beta minus decay. Next the beta plus decay. Beta plus decay, here proton is converted into proton, 1 charge, 1 mass. Here neutron, 0 mass, 0 charge, 1 mass. Plus, we need to conserve this quantity. Here is a 1, here is a 0, means here we need to add 1. Okay, here mass is a conserve equal, then here we can take the 0. Means this particle is known as a positron with some amount, Q amount of energy will be emitted in this case. Okay. Next. Okay. Now see here. Neutron have slightly greater mass. Neutron have slightly greater mass as compared to the proton. Means here we can take neutron have greater mass than proton. Means here suppose we can find out the Q. Then what is this one? Q is equal to mass of neutron minus mass of proton plus mass of electron bracket complete into C square. This much amount of Q amount of energy is liberated in this reaction. Yes or no? This much amount of energy will be emitted. Next one. Here is a 1 proton is converted into a neutron. Proton is converted into neutron. We know that Q is equal to positive. Only possible if reactant mass is greater than product mass. Reactant mass is greater than product mass. But see here proton have lower mass as compared to the neutron. This difference is negative. This difference is negative. This is a possible? Yes or no? this is mass is greater, this energy is greater as compared to the reactant. As compared to the reactant. This one is possible? Yes or no? Because here Q is equal to mass of proton minus mass of neutron plus mass of positron into C square. We know that mass of proton and electron and positron have same. This is the antineutrino particle to do each other's. Okay. Then this is a extra energy. Yes or no? This is a slightly greater energy. Then and then only this reaction is possible. Because mass of proton is less as compared to the mass of neutron. Mass of neutron. Yes or no? Means here we're getting the negative energy. This one is possible. Then this extra energy getting from binding energy. Getting from binding energy. We know that E is equal to mc square. E is equal to mc square or delta m c square. Okay. Means here we're getting the energy. It can be written as E upon c square is equal to delta m. Yes or no? Delta m amount of mass will be decreases and this is converted in the form of energy. And this energy getting from binding energy. Binding energy. जब हमें बाइंडिंग से वो एनर्जी मिलती है तब वो कॉन्जर्व हो जाती है. समझ में आ गया? ये क्यों हो रहा है? क्योंकि प्रोटॉन का मास जो है कम है एज कम्पेयर टू द न्यूट्रॉन. यस और नो? और हमारा जो पहले कम एनर्जी से ज्यादा एनर्जी नहीं मिल सकती. वो दिस मस्ट बी कॉन्जर्व होनी चाहिए. यस और नो? और ये कैसी कॉन्जर्व हो जाती है? बिकॉज मास ऑफ द प्रोटॉन इज लेस. मास ऑफ प्रोटॉन इज लेस एज कम्पेयर टू द न्यूट्रॉन. यस और नो? इसलिए क्या होता है? सम अमाउंट ऑफ एनर्जी एब्जॉर्ब फ्रॉम न्यूक्लियस. यस और नो? और हमारी जो बाइंडिंग एनर्जी रहती है, बाइंडिंग एनर्जी से वो एनर्जी क्या होती है? कन्वर्ट हो जाती है. समझ में आ गया? कौन से केस में? Q इज इक्वल टू MP मींस पॉजिट्रॉन केस में. पॉजिट्रॉन केस में व्हाई? बिकॉज प्रोटॉन हैव द लोअर मास एज कंपेयर टू द न्यूट्रॉन स्मॉल. दिस वन इज दिस अमाउंट ऑफ एनर्जी कहां से ली जाती है? हमारी बाइंडिंग एनर्जी से ली जाती है. समझ में आ गया? Q इज इक्वल टू हाउ मच देन? दिस इज इक्वल टू दिस वन. दिस एनर्जी गेटिंग फ्रॉम दिस बीटा माइनस. ओके. This one is a general first reaction. Yes or no? But समझ हम क्या कहेंगे? हमारी जो रिएक्शन है, देखिए हमारी जो रिएक्शन है, कोई भी रिएक्शन हो, चाहे वो देख रहे हम. सपोज ZX है, okay, as decay into Z1Y plus A, Z1Y plus A minus 1E0, or we can write down this is nothing but beta minus, okay, beta minus plus Q, okay. आपको पता है कि लॉ ऑफ कंजर्वेशन ऑफ एनर्जी, सपोज हमने ये जो रिएक्टेंट है इसमें 5 मेगा इलेक्ट्रॉन वोल्ट अमाउंट ऑफ एनर्जी मिल सकती है. समझ लीजिए ये 5 मेगा इलेक्ट्रॉन वोल्ट एनर्जी है, तो आरएचएस में भी कितनी होनी चाहिए? 5 मेगा इलेक्ट्रॉन वोल्ट एनर्जी होनी चाहिए. यस सर, नो? सिंपल सी बात है, लॉ ऑफ कंजर्वेशन ऑफ एनर्जीज. ओके, लेकिन होता है क्या यहां? देखिए हमारा जो ये पार्टिकल है, दिस इज अ वेरी वेरी लार्ज एज कंपेयर टू द बीटा. बीटा इज अ वेरी वेरी स्मॉलर पार्टिकल. बीटा इज अ वेरी वेरी स्मॉलर वन. ओके, बीटा इज अ वेरी स्मॉलर वन. बीटा इज अ वेरी वेरी स्मॉलर पार्टिकल. सपोज जो हमारी 5 मेगा इलेक्ट्रॉन वोल्ट जो एनर्जी है ये आरएचएस में भी होनी चाहिए. ठीक है, हमारा जो ये वाई पार्टिकल है, दिस इज अ वेरी वेरी लार्ज बीटा, sorry, y particle is a very large, okay, and this very large particle absorbed very small amount of energy, very small energy. This is approximately equal to 0, this approximately equal to or 0.1 mega electron volt. 0 वोल्ट और 0. मेगा इलेक्ट्रॉन वोल्ट. मींस आप समझ लीजिए कि वाई पार्टिकल ने हमें कितनी एनर्जी ली है? अटैक एज अप्रोक्सीमेटली इक्वल टू 0 और इज अ वेरी वेरी स्मॉलर वन. ओके, मतलब क्या हो गया? मतलब जो भी रिमेनिंग एनर्जी है वो कौन लेके जा रहा है? वो बीटा पार्टिकल लेके जा रहा है. समझ में आएगा आपको? मतलब हमारी 5 मेगा इलेक्ट्रॉन वोल्ट है वो बीटा के लिए ही मिलनी चाहिए, बीटा को ही मिलनी चाहिए. ऐसा ना, मतलब हमारे 5 है, इसमें समझ कंसिडर ही ले लिया कि 0.1 मेगा इलेक्ट्रॉन वोल्ट एनर्जी किसने लिया है? वाई ने लिया है. तो बची हुई जो 4.9 मेगा इलेक्ट्रॉन वोल्ट एनर्जी है वो किसको जाएगी? बीटा माइनस को जाएगी. बीटा माइनस को जाएगी. ये सर ना. तो आप यहां कंसीडर कर लेंगे, एक्सपेरिमेंटली चेक कर लेंगे, तो बीटा पार्टिकल है, वो बीटा पार्टिकल कितनी एनर्जी ऑब्जर्व कर सकता है. दिस वन इज कांस्टेंट वेरिएबल, दिस एनर्जी इज अ वेरिएबल. ऑलवेज मेमोराइज बीटा, every beta have the different energies. This one is not fixed. Okay, you can choose the single one atoms. Again, beta will be have the different energies. Okay, now suppose first one, मान लीजिए कि बीटा ने 3 मेगा इलेक्ट्रॉन होल्ड इतनी एनर्जी किया है, ले लिया. 3 मेगा इलेक्ट्रॉन होल्ड एनर्जी लिया है. ठीक है, ये समझ लीजिए उन्होंने 3 ले लिया. कितना टोटल, तो कितना है हमारे पास टोटल 5 मेगा इलेक्ट्रॉन होल्ड है. इसमें बीटा कितना ले रहा है, 3 मेगा इलेक्ट्रॉन है. मतलब रिमेनिंग जो 2 है वो किसको जानी चाहिए, वाई को जानी चाहिए. ठीक है, लेकिन आपको पता है वाई इज अ वेरी वेरी लार्जर पार्टिकल, then absorb this getting a very very small amount of energy. मतलब here is 3 plus 0.1 is equal to 3. then ये 2 मेगा इलेक्ट्रॉन वोल्ट जो एनर्जी है हमारी यहाँ कहां जाती है, कहां जाती है ये, yes or no? ये तो कंजर्व हो ही नहीं रही है. समझ में आ गया आपको, ये कंजर्व हो ही नहीं रही है. नेक्स्ट टाइम समझ लीजिए कि नेक्स्ट टाइम दूसरा जो हमारा बीटा है उन्होंने कंसीडर कर लीजिए कि 4 मेगा इलेक्ट्रॉन वोल्ट एनर्जी ली है. मतलब दूसरी जो एनर्जी वो कितना हो गया, 4 मेगा इलेक्ट्रॉन, वो कितना हो गया 0.1 मेगा इलेक्ट्रॉन वोल्ट, मतलब 4.1 हो गया. लेकिन 0.9 मेगा इलेक्ट्रॉन वोल्ट एनर्जी कहां गई है, आगे समझ में. नेक्स्ट हमने चूज कर लिया, सपोज ये ले रहा है 2.5 मेगा इलेक्ट्रॉन वोल्ट एनर्जी. 2.5 प्लस 0.1 इज 2.6. मतलब हमारी जो रिमेनिंग 1.6 है और 2.4 है वो कहां गई एनर्जी, वो कहां गई एनर्जी. दिस इज अ वेरी इंपॉर्टेंट. ओके, नेक्स्ट ऑफ एनर्जी तो नहीं कौन सा एक्सपेरिमेंटली हम ये प्रूव कर दिया गया. बीटा फर्स्ट बीटा है हमारा, इसका एनर्जी है, और दूसरा बीटा है वो 4 है, तीसरा बीटा है वो इसकी एनर्जी. तो एनर्जी कॉन्जर्व ही नहीं हो रही बीटा में, एनर्जी कॉन्जर्व ही हो नहीं है बीटा में. तो ये ऐसा क्यों हो रहा है, इसका मतलब क्या है, और कुछ तो प्रेजेंट है इसमें, तब तो ये एनर्जी मैच नहीं हो रहा है, तब तो ये एनर्जी मैच नहीं हो रहा है. तो आगे देखिए, ये देखिए हमें मास को कंजर्व करेंगे तो ये देखिए यहां ये है, यहां ये है. ठीक है, यहां मास बीटा के लिए 0 है, मतलब मास कंजर्व है. तो हमारा कुछ भी पार्टिकल आ जाए, कुछ भी कोई भी हो प्रेजेंट, इसके लिए तो मास 0 होगा. क्यों, कि तो ऑलरेडी कंजर्व हो रहा है. इसका 0 होगा तभी वो कंजर्व हो जाएंगे. ठीक है, मतलब मास से वो पार्टिकल आइडेंटिफाई नहीं कर सकते, मास के लिए वो पार्टिकल आइडेंटिफाई नहीं कर सकते. समझ में आ गया, मतलब यहां कुछ तो होगा, यस और नो, लेकिन हम आइडेंटिफाई नहीं कर रहे. किसके बेसिस से, मास के बेसिस से. नेक्स्ट चूज कर लीजिए जेड. देखिए ये जो जेड है हमारा एटॉमिक नंबर है, ये जेड है, ये जेड +1 है, ये -1 है, +1 -1 गेट कैंसल. मतलब हमारा जो भी पार्टिकल रहेगा इसके लिए कोई एटॉमिक नंबर नहीं रहेगा, इसके लिए कोई मास नंबर नहीं, कुछ एटॉमिक नंबर नहीं है. ऐसा नो, मतलब इसके लिए कोई चार्ज भी है नहीं है, चार्ज नहीं है, मास नहीं है. तो फिर पार्टिकल कैसे आइडेंटिफाई करेंगे, कैसे आइडेंटिफाई करेंगे, ऐसा नो. लेकिन कुछ तो पार्टिकल डेफिनेटली है कि जो यहां से कुछ एनर्जी ले रहा है, एनर्जी कुछ ले रहा है. समझ में आ गया, जो भी पार्टिकल होगा इनका मास कितना होगा, 0, इनका चार्ज कितना होगा, 0, ऐसा नो. देन scientist Paulis, you know that Paulis exclusive principle. Paulis say that कि ये जो ये तो देखिए देख लिया हमने कि वो मास के हिसाब से भी हम कुछ आइडेंटिफाई नहीं कर रहे. सेकंड वन चार्ज के हिसाब से भी वो आइडेंटिफाई नहीं हो रहा है. तो नेक्स्ट जब उनका पिक्चर ले लिया तो उसमें एक पार्टिकल आइडेंटिफाई हुआ है, किसमें, पिक्चर में. एंड दिस इज नोन एज anti-neutrino. This is known as a anti-neutrino. Anti-neutrino. Okay, here is a beta minus electron. This means anti-neutrinos is a Neue bar. ठीक है. What is the property of these particles? This is a chargeless particle. Chargeless particle. Okay. Its velocity is the speed of light. The velocity is the speed of light. Its mass 0. Mass 0. What is the penetrating power? Penetrating power is a very very high of this particle. Yes or no? And what is the spin of this particle? What is the spin of this particle? Spin of the particle is a plus or minus 1 by 2. Plus or minus 1 by 2. Who invent that? Pauli invents that. How? Using the picture. Using the picture, you can say one particle is present here. This particle is known as an antineutrino or neutrino. Yes or no? This is a depends upon here. Particle is a beta minus, means here is antineutrino. Here is a beta plus, here is a neutrino. Okay? Means first one एनर्जी हमारा कंजर्व नहीं हो रहा था. ये देखिए अभी वो कंजर्व हो जाएगा. कैसे कंजर्व हो जाएगा? समझ मान लीजिए कि मेरे बेटा ने कितनी एनर्जी ली है 3 मेगा इलेक्ट्रॉन वोल्ट. मतलब बची हुई कितनी है 1.9. बिकॉज 0.1 एनर्जी किसने लिया है? Y ने लिया है. 3 plus 0.1. What is the remaining? 1.9 mega electron volt energy going to the Nevi particles. Nevi particles. सेकंड केस में मान लीजिए मेरे बीटा ने कितनी एनर्जी ली है 4 मेगा इलेक्ट्रॉन. मतलब बची हुई कितनी है 1 है. उसमें पॉइंट कितना 0.1 किसको गया? Y को गया. मतलब कितना रिमेनिंग है 0.9. वो किसको जाएगा? न्यू को. अभी हमारी एनर्जी क्या हो जाएगी? कंजर्व हो जाएगी. मतलब 4 प्लस 0.1 प्लस 0.9 इज इक्वल टू 5. नेक्स्ट 4 3 प्लस 0.1 3.1 प्लस 1.9 इज इक्वल टू 5. मतलब अभी क्या हो रहा है? हमारा एनर्जी कंजर्व हो रहा है. एनर्जी कंजर्व हो रहा है. कब? जब हम क्या ले रहे हैं यहां एंटीन्यूट्रिनो ले रहे हैं. ठीक है, समझ में आ गया? ये जो हमारा पार्टिकल जब तक हमने इन्वेंट ही नहीं किया था तब तो कुछ गड़बड़ हो रही थी. एक्सपेरिमेंटली हमारी वैल्यू तो बीटा की अलग आ रही थी. हमारा जो कंजर्वेशन ऑफ एनर्जी है वो भी फॉलो नहीं हो रहा था. ऐसा ना, इसलिए पाउली ने वो इन्वेंट कर दिया. किस में इन्वेंट कर दिया? पिक्चर में. ऐसा ना, वो देख गया वो पार्टिकल्स. आगे समझ में? वो बाकी कुछ प्रॉपर्टी से वो आइडेंटिफाई क्यों नहीं हो रहा था? बिकॉज इनका चार्ज है वो 0 था, मास भी 0 था, चार्जलेस था पार्टिकल. ओके, उसकी वेलोसिटी इज द स्पीड ऑफ लाइट. ओके, and the same thing here also in a neutron. Suppose we consider the neutron 1 and 0, 0 and 1 is converted into proton 1p1. Okay, means here we need to conserve the charge. Means we can take here is -1 e0. Okay, matlab here is a electron, here is a particle, hence we can take here is a antiparticle Nevi bar. Why we can take this here is a bar? Because here is a spin momentum we need to conserve. Spin momentum is we need to conserve. Suppose before of finding the antineutrino, what is the reaction? 0 and 1 is converted in the form of 1p1 plus -1e0 plus q. Here suppose मान लीजिए what is the spin of proton? Spin of proton is 1 by 2. Spin of proton is 1 by 2. What is the spin of proton? 1 by 2. What is the spin of neutron? 1 by 2. What is the spin of electron? Spin of electron 1 by 2. Spin of energy is no spin. Yes or no? Means here spin is not conserved. Spin momentum is not conserved. Now we can say the spin here 1 by 2 is -1 by 2. -1 by 2 plus 1 by 2 get cancelled. -1 by 2 and 1 by 2 get cancelled. And here spin momentum also conserved. Same the second reaction. Check the second reaction also. 1p1 is a decay into 0 and 1 plus 1e0 plus here is this is known as a positron, antiparticles. Okay, here mass number is conserved, atomic number also conserved. Next means here spin is not conserved. Why? Here is a 1 by 2, here is a 1 by 2, here is a -1 by 2. Means new particle must have the spin is equal to how much? +1 by 2. +1 by 2 means here we can take the neutrino. We can take the neutrino for positron, antineutrino for beta minus. Got it? What is the invention of this one? This is known as a antineutrino particle or neutrino particle. Once you getting the neutrino particle, both conservation of energy as well as conservation of momentum, both are possible in this case. आपको समझ में आ गया कि हमारे पास ये जो बीटा पार्टिकल्स है, बीटा सबसे पहली बात ये है कि हमें बीटा कैसे मिल रहा है. समझ में आ गया कैसे आप मिल गया ये? तो ये सेंटर में तो कोई इलेक्ट्रॉन होने का चांस होता ही नहीं है. ठीक है, लेकिन अभी वो क्या हो रहा है, न्यूट्रॉन इज कन्वर्टेड इन द फॉर्म ऑफ प्रोटॉन, न्यूट्रॉन इज कन्वर्टेड इन द फॉर्म ऑफ प्रोटॉन. एट दैट टाइम we need to the conserve the system. At that time some particle ऐसा क्रिएट हो जाएगा कि जिनका जो चार्ज है वो माइनस रहेगा और मास कितना होगा, 0. अभी वो हम कंसीडर कर लेंगे यार चार्ज किसका -1 है और 0 मास है, तो समझ लीजिए वो इलेक्ट्रॉन है. तो इसमें क्या क्रिएट होगा, वो जनरेट, दिस इज इलेक्ट्रॉन इज अ जनरेटेड इलेक्ट्रॉन. कैसे जनरेट होता है समझ में आ गया आपको, कि न्यूट्रॉन इज कन्वर्टेड इन द प्रोटॉन और प्रोटॉन इज कन्वर्टेड इन द न्यूट्रॉन इनसाइड द न्यूक्लियस. आगे समझ में, जैसे कि हम यहां से वहां जब इलेक्ट्रॉन करते हैं तो प्रोटॉन क्रिएट होता है. सिमिलरली इनसाइड द न्यूक्लियस आल्सो इलेक्ट्रॉन क्रिएटेड cause of beta decay. Your proton is converted in the form of neutron or neutron is converted in the form of proton. Initial one reaction is only this one, yes or no? But we can experimentally this some values are not satisfactory. Energy and spin momentum. The new particle is invented by the Pauli by using spin picture. Okay, at that time we can find out this particle is known as anti-neutron. Why energy is not conserved? This why particle getting is approximately equal to 0 energy, whatever the particle energy going to the beta only. But beta also not attaining 100% energy, is attaining 30, 40 or whatever this one, 3, 4, 4.1 like that. Is remaining energy going to the this particle. Now we can write down this reaction. Then energy as well as spin momentum both are conserved in this case. Conserved in this case. Next one is electron capture. Already we can study the beta plus and beta minus. Now we can study the electron capture. Electron capture. Okay. Now suppose we consider this one is a X atom. X atom. Then this is equal to how much? ZXA. ZXA. हमारे जो एनर्जी लेवल्स होते हैं, ठीक है, हमारा ये सेंटर में न्यूक्लियस है. Okay. Here inside the nucleus we know that proton and neutron are present. Okay. And suppose we consider that this one is a different energy levels, K cell, L cell, M cell. Okay, but inner cells are very close to the nucleus. Inner cell are very close to the nucleus. Yes or no? These are very close to the nucleus. Yes or no? Very close to the nucleus. ठीक है. और हमारा जो न्यूक्लियस रहेगा वो जो क्लोजर ऑर्बिट के जो भी इलेक्ट्रॉन्स होंगे वो इलेक्ट्रॉन्स कभी कभी क्या करेंगे, मगअप करेंगे. ठीक है, उसको कैप्चर करेंगे. समझ में, ये जो इलेक्ट्रॉन है यहाँ न्यूक्लियस में नहीं क्रिएट हो रहा है, ये क्या हो रहा है, हमारा जो इलेक्ट्रॉन है, सपोज ये मान लीजिए कि वो के सेल है, वो के सेल में इलेक्ट्रॉन्स है, तो हमारा न्यूक्लियस क्या करेगा, वो जो के सेल का जो इलेक्ट्रॉन्स है वो कैप्चर कर लेगा. क्या कर लेगा, कैप्चर कर लेगा. समझ में आ गया. दिस इज नॉट क्रिएटेड इनसाइड द न्यूक्लियस, दिस न्यूक्लियस इज कैप्चर द इलेक्ट्रॉन क्लोजिंग ऑर्बिट. जो हमारी क्लोज ऑर्बिट है इसमें का जो इलेक्ट्रॉन है वो कैप्चर कर लेगा. समझ में आ गया. मतलब हमारा जो इलेक्ट्रॉन है क्लोज ऑर्बिट का वो क्या करेगा, ये जो हमारा न्यूक्लियस है वो एब्जॉर्ब कर लेगा. ठीक है, और इलेक्ट्रॉन -1 E0 और ये एब्जॉर्ब करके क्या करेगा, एक से एलिमेंट जो है वो वाई में कन्वर्ट हो जाएगा. वाई में कन्वर्ट हो जाएगा. मान लीजिए हियर इज अ z, हियर इज अ -1, means we need to conserve this quantity. Here mass a plus 0 is equal to a. Z minus 1 means here also we need to write down the Z minus 1. Means this X element is converted in the form of Y element with absorbing or capturing the electron from closer orbit. Closer orbit. Closer orbit हो गए, वो जो हमारा न्यूक्लियस है वो मिनिमम एफर्ट से वो क्या करता है, एब्सॉर्ब कैप्चर कर लेता है. समझ में आ गया. दिस इफेक्ट इज नोन एज इलेक्ट्रॉन कैप्चरिंग. इलेक्ट्रॉन कैप्चरिंग. अल्फा डीके, beta plus decay, beta minus decay, and beta plus beta minus beta minus. How to memorize this? Beta plus and beta minus plus product positron. अभी हम थोड़ा ग्राफिकल रिप्रेजेंटेशन देखेंगे. अभी हम जरा सा थोड़ा सा ग्राफिकल रिप्रेजेंटेशन देखेंगे, ठीक है। हम क्या करेंगे अभी, वाई डायरेक्शन से प्रोटॉन लेंगे और इन एक्स डायरेक्शन से एक्स डायरेक्शन से प्रोटॉन ले लेंगे और वाई डायरेक्शन से न्यूट्रॉन ले लेंगे, ठीक है। न्यूट्रॉन टेकिंग इन वाई डायरेक्शन एंड प्रोटॉन इन एक्स डायरेक्शन, ओके। प्रोटॉन इन एक्स डायरेक्शन, proton along the x direction, neutron along the y direction. Now we know that when atom is more stable, when number of proton and number of neutrons are equal, means here repulsion or whatever the factor is a very small amount, yes or no? Means this atom is more stable, okay. Means suppose we consider this is a line where number of proton is equal to number of neutrons. Means in these lines, whatever the elements are present, this one is a more stable one. More stable one, yes or no? Next, which one is a more stable one? Now suppose here, suppose we can take one, what is the stability lines? In this case, stability line. Stability line, this one is stability line, and here is for beta. This is the light lines, okay. This is the light lines. Means here is a beta decay is possible. Here, suppose we consider here we can take the ratio of neutron versus proton, and here also we can take the neutron versus proton ratio. Okay. Now see here in this region, which particle is larger? Proton is larger or neutron is larger? So in below case, here proton number is larger. Proton number is larger, okay. Why? Because in this x direction we can take the protons. Means here proton is larger. Proton is larger as compared to the neutron. Means here beta plus decay transition is possible, beta minus is decay possible. Here beta plus is possible. Why beta plus is positive? Possible. Beta plus is possible. Why? Because here proton is converted into neutron. Proton is converted into neutron. Proton is converted into neutron and going to the stability. Okay. Yes or no? Here proton is converted into neutron. How? See here. Now for this region, proton is converted into neutron. Plus here charge is 1, mass is 1. Means here we need to, charge is equal to how much? 0. Here mass is equal to 1. Mass is conserved, no problem. But here charge is not conserved. Means here which particle is emitted? Plus 1 and 0 charge. And this particle is known as plus 1 charge and 0 particle is known as positron. Yes or no? Means for this region, n upon p ratio is a smaller one. This ratio is a smaller one. Means here tends to stability. Proton is converted in the form of neutron. Proton is converted in the form of neutron. Means which decay is possible in this region? Here beta plus decay is possible. Means whatever the element present in this region, this is converted with the emitting of the beta particles. Emitting with the beta particles. See here neutron upon proton ratio. Here neutron upon proton ratio is greater than 1. This is greater than 1. Means here neutron number is larger. Neutron number is larger. And now this we need to stability of this atom. Then what happens? This neutron is converted into proton. Neutron is converted into proton. Means neutron is converted into proton. Means particle is emitted. We know that neutron is converted into proton. Yes or no? Here charge 0, mass 1, charge 1, mass 1. Means here we need to conserve the charge. Take minus 1, mass is conserved. Take 0. This particle is known as electron. This one is a particle. We can take antiparticles, okay, or antineutrino. Why we need to take antineutrino? Always memorize particle and antiparticle, because here spin is 1 by 2, here spin is 1 by 2, here spin is plus 1 by 2, then antineutrino spin is minus 1 by 2. आगे समझ में, हम क्यों एंटी ले रहे हैं? समझ में आ गया आपको? मतलब यहाँ इलेक्ट्रॉन है, यहाँ एंटीन्यूट्रिनो ले लो, यहाँ एंटी पॉजिट्रॉन है, न्यूट्रिनो ले लो. Okay, means there is a new suffix for electron neutrino. Electron neutrino. Yes or no? Here spin is 1 by 2. Here spin is 1 by 2. Here spin is minus 1 by 2. Here spin is 1 by 2. Means here spin and momentum also conserved in this case. Got it? Again, समझ में, in this region beta plus decay is possible. In this region beta minus decay is possible. Why? Because here neutron is converted in the form of proton. Why? Because here neutron is larger as compared to the proton. We need to stabilize this one. Number of proton is equal to number of neutron. This condition must be satisfied. हमारी जो ये कंडीशन है ये जो सेटिस्फाई हो जाएगी तो स्टेबल हो जाएगी. आगे समझ में. इसीलिए वो न्यूट्रॉन इज कन्वर्टेड इन द फॉर्म ऑफ प्रोटॉन, बीटा माइनस डीके. प्रोटॉन इज कन्वर्टेड इन न्यूट्रॉन, बीटा प्लस डीके. Got it? Why we need to take this one? Next, energy. We can take energy along x-axis. Energy along x-axis. Here along x-axis, and we can take here beta particles. Beta particles. Okay. Beta along this particle. Number of betas. Number of beta particle, and we can take this direction as energy. This direction as energy. Okay. This nature of this is equal to like that. This nature is like that. Okay. Means here number of beta particle increases. Number of beta particle increases. Next, number of beta particle is decreases. Okay. Number of particle is maximum at 1/3 of E max. 1/3 of E max. Number of particle is maximum at what value of energy? 1/3 of E max. Okay. Next. This is the number of particle versus energy. Second one, we can take the number of beta particles, number of neutrino particles, number of neutrino particles, neutrino and antineutrino particles versus energy. Number of neutrino versus. We know that in a reaction, suppose we can take the reaction X, Za can be converted into Z plus 1 or minus 1, plus 1 or minus 1. Plus 1 or minus 1, y, a, here beta plus or minus, plus here neutrino or antineutrino, neutrino or antineutrino. We know that in we cannot consideration of this antineutrino. At that time, law of conservation of energy is not satisfied. Yes or no? We can take this particle, then law of conservation of energy is a valid one. Yes or no? Means here, suppose beta is total energy is equal to 5 mega electron volt, and suppose beta particle take the 3 mega electron volt. Then what is the energy of the neutrino particles? At that time, neutrino particle energy is equal to 2 mega electron volt. Why? Because this one particle take is a very smaller one. This can be neglected, or we can take the, I think that is 0.1 mega electron volt. Got it? Means here is 3, here is 2, here is 4, here is 1, here is a 1.5, here is a 3.5. Means this is a balancing, okay, and is the addition is equal to. Means here total Q is equal to E of beta plus E of nu. आप समझ लीजिए ये हमारे न्यू बीटा पार्टिकल्स कितने हैं? बीटा पार्टिकल्स 0. बीटा पार्टिकल्स 0. आगे समझ में? Beta particles have the energy is equal to 0. Sorry. Beta particle have the energy is equal to how much? 0 suppose. At that time, maximum energy or maximum, here beta particle is 0. Maximum energy. Or we cannot start here like that a small thing. Next here. Suppose हमारी यह बीटा पार्टिकल की एनर्जी है वो है. ठीक है. टोटल एनर्जी सपोज इतनी होगी. समझ में आ गया? सपोज ये कंसीडर लगी 2 है. This is the energy of a beta particle. At that time, what is the energy of neutrino particle? At that time, neutrino of energy particle is equal to 3. Neutrino of particle energy is equal to how much? 3. Now, here, energy increases. Which energy increases? Beta particle energy increases. Then neutrino particle energy is decreases. Energy particle is decreases. Got it? This is the nature reverse of that, because total is equal to how much? Constant one. Wait, yes or no? This addition is equal to how much? Constant. Means here is the minimum energy of a beta particle. Here maximum energy of neutrino particle, because total is equal to how much? Total is equal to Q. Here total is equal to 5. Then here is a 3. Then here is 2. Here is a 2.5. Here is a 2.5. Here is a 2. Here is a 3. Here is a 1. Here is a 4. Here is a 3. Here is a 2. And so on. Got it? This is the nature. Number of beta particles with the energy. Number of neutrino particle with the energy. Yes, any doubt in this case? I think no. Got it? Simple. आपको समझ में आ गया? ये हमारी जो बीटा की एनर्जी जितनी मतलब जितनी होगी, ठीक है, और न्यूट्रॉनों की दो मिला के हमको कांस्टेंट लाना है, ये टोटल होना चाहिए। समझ में आ गए? ये कम है तो इसके हिसाब से वो ज्यादा होगी, ये जैसे बढ़ेगी वो वैसे कम हो जाएगी, वो वैसे बढ़ेगी वैसे उनकी कम हो जाएगी। ठीक है, ये दोनों का रिलेशन है, क्योंकि टोटल तो हमें इक्वल कांस्टेंट वैल्यू ही लाना है। दिस विल बी फिक्स, दिस इज नॉट अ वेरिएबल। ओके, मींस ये हमारी कम है तो ये ज्यादा होगी, ये ज्यादा है तो वो कम होगी। दिस इज द रिलेशन बिटवीन नंबर ऑफ बीटा पार्टिकल एंड एनर्जी एंड नंबर ऑफ न्यूट्रॉन पार्टिकल एंड एनर्जी। ये समझ में आएगा? Here number of proton is greater than number of neutrons. We need to know the stability. Beta plus decay is possible. Here there is a beta minus. Why? Because your number of particle, number of neutron is greater than proton. This number of neutron is converted into proton. What is the important role of a neutrino? Important role of a neutrino here is a conservation of spin momentum, and the second one is a conservation of energy. Conservation of energy समझ में आएगा आपको? ये तो आपको डायरेक्टली समझ में आएगा। सेकंड वन आल्सो वेरी इंपॉर्टेंट। मैंने जब आपको बताया था कि हमारे 5 मेगा इलेक्ट्रॉन वोल्ट एनर्जी है टोटल, तो इसमें 2.5 बीटा को गया तो 2.5 किसको जाएगा? न्यूट्रिनो को जाएगा। ठीक है, तब ये हमारा जो बैलेंस है वो हो जाएगा। कंजर्वेशन ऑफ एनर्जी है वो क्या हो जाएगी? इसमें सेटिस्फाई हो जाएगी। आगे समझ में? दिस व्हाट इज द इंपॉर्टेंट रोल ऑफ द न्यूट्रिनो पार्टिकल is a two factors is a very important. One is the conservation of energy and the second one is a momentum conservation. Who invented this particle? Paul is invented in picture. Yes or no? I think in the last exam 2020 they asked one questions on this thing, neutrinos. Okay, what is this question? Set 2020 questions. Set 2020 question. The beta particle is emitted by a radioactive source. Have a contain energy spectrum with endpoint energy Emax. With endpoint energy Emax. This is due to sharing of. This word is very important. Due to sharing of disintegration energy. Option number 1, emitting nucleus and beta particles in the form of recoil energy. Beta particle in the form of recoil energy. Second one, neutrino and gamma ray. Third one, beta particle and neutrino in the nucleus. Beta particle and neutron in the nucleus. Okay. Neutron in the nucleus. Space division. In the nucleus. And fourth one, beta particle and neutrino. Suppose we can take the reactions. ZX. Okay. Which particle is emitted? Beta emitted. Okay. This one is a Y particle plus beta plus neutrino. This may be plus neutrino, antineutrino, whatever. We know that here suppose the 5 mega electron volt energy given to the system, and this 5 electron energy how to distribute it or how to sharing this 5 electron energy in RHS side. Disintegration means Q value. Simply disintegration means Q value. Okay, now we know that how to Q value. Write down here energy of beta particle plus energy of neutrino particles. मीन्स इसमें क्या पूछा है आपको? सिंपली ये बताया है हमारी जो भी एनर्जी है सिस्टम की, ये एनर्जी आरएचएस में कौन से पार्टिकल में शेयर हो जाएगी। तो आपको पता है कि Y is a very heavy particle. This absorbs very small amount of energy. Means whatever the energy sharing in only two particles. This one is which two particles? Beta and neutrino. Yes or no? Means which option is correct? Emitting nucleus and the beta particles. न्यूक्लियस का कोई एक्सक्यूज नहीं है, रिकॉइलिंग एनर्जी का कोई रिलेशन है ही नहीं इसमें रिकॉइलिंग का। ठीक है, तो ये ऑप्शन नहीं आ जाएगा। ठीक है, न्यूट्रिनो यस ओके, न्यूट्रिनो के लिए शेयर हो जाएगी, नो प्रॉब्लम। बट ये कहां से गामा कहां से आ गई? हम तो ये बीटा स्टडी कर रहे हैं, मतलब ये भी ऑप्शन हो नहीं सकता क्योंकि गेम आ रही है, यहाँ नहीं स्टडी कर रहे हैं। ठीक है, ओके, आंसर हो गया। नेक्स्ट बीटा पार्टिकल। ओके, नो प्रॉब्लम। बीटा पार्टिकल के लिए तो थोड़ा शेयरिंग हो जाएगा, वही है। ठीक है, बीटा प्लस न्यूट्रिनो है तो बीटा के लिए कुछ ना कुछ जाएगा। And neutron in the nucleus. तो ये न्यूट्रॉन के लिए तो नहीं स्थिर होती। आगे समझ में? मतलब हमें बीटा के लिए मिल जाएगी लेकिन न्यूट्रॉन के लिए वो स्थिर नहीं हो जाएगी। ठीक है, मतलब सी ऑप्शन आल्सो नॉट करेक्ट। Going to the D, remaining is only D. Okay, it's a beta particle and a neutrino. Beta particle and neutrino means whatever the energy sharing with the beta particle and neutrino particle. Beta particle and neutrino particle. Always memorize. This energy contribution is neglected or is compared to the zero. Got it? Means whatever the disintegration is Q value is sharing with beta particle and a neutrino. Beta particle and a neutrino. कभी कभी आपको स्ट्रेट फॉरवर्ड क्वेश्चन पूछा जा सकता है कि बीटा प्लस और बीटा माइनस के रिलेटेड, और सपोज वी कंसीडर सपोज व्हेन इज अ बीटा प्लस डीके एंड द हियर एनर्जी बीटा प्लस पार्टिकल एंड द एनर्जी ग्राफ. ओके, नाउ वी नो दैट द बीटा प्लस डीके zxa decay into y particles plus, always memorize बीटा प्लस. आपको जनरल समझ में नहीं गया यार, बीटा प्लस में भी पॉजिट्रॉन इमिट हो गया या इलेक्ट्रॉन, तो ऑलवेज मेमोराइज बीटा प्लस मींस प्लस पार्टिकल इज इमिटेड एंड बीटा माइनस माइनस पार्टिकल इज इमिटेड. माइनस मींस इलेक्ट्रॉन, प्लस मींस पॉजिट्रॉन. गॉट इट? मतलब बीटा प्लस राइट को प्लस देखिए, बीटा माइनस राइट को माइनस देखिए. आगे समझ में? मुझे क्या करना है अभी, बीटा प्लस पार्टिकल लेना है तो यहाँ कितना लिख दूंगा, +1. ओके, +1 e to the power. ऑलवेज मेमोराइज द चार्ज इज इक्वल टू हाउ मच, मास इज इक्वल टू 0, चार्ज इज इक्वल टू +1. ये +1 है, यहाँ z है, तो यहाँ मुझे क्या करना पड़ेगा, माइनस करना पड़ेगा, प्लस करना माइनस. ओके, z -1 और जो a है वो सेम ही रहेगा. ठीक है, ये मेरा पार्टिकल है, एंटी पार्टिकल है, ये मेरा एंटी पार्टिकल है, तो मुझे यहाँ क्या लेना पड़ेगा, न्यूट्रिनो है ना, ये इलेक्ट्रॉन है इसलिए मैंने न्यू सफिक्स e ले लिया. ठीक है, मिल गया. अभी देखिए मैंने जो लास्ट टाइम एनर्जी निकाली थी, फर्स्ट टाइम मैंने यहाँ से स्टार्ट किया था, सेकंड टाइम मैंने वहां से स्टार्ट कर दिया था. ठीक है, तो ये क्या हो जाएगा हमारा, ये इनिशियल वन नेचर इज लाइक दैट. दिस इज फॉर बीटा प्लस, दिस इज फॉर बीटा प्लस डीके, दिस इज फॉर बीटा प्लस डीके. अब देखिए बीटा प्लस, हम बीटा प्लस देखेंगे तो वी नो दैट ये जो एनर्जी लेवल्स है यहाँ शिफ्ट हो रही है, 1/3 ऑफ E max, 1/3 ऑफ E max. ओके, अब देखिए कैसी शिफ्ट हो रही, तो आप देखिए सेकंड नेचर आल्सो बीटा माइनस का नेचर, तो पता चलेगा ये कहाँ शिफ्ट हो रहा है. तो बीटा माइनस का हो जाए यहाँ ऐसे हो जाएगा. ठीक है, मतलब बीटा माइनस के लिए हियर इज 1/3 ऑफ E max, 1/3 ऑफ E max. अब ये आपको समझ में आएगा कि ये हायर लोअर के लिए कैसे शिफ्ट हो रहा है. मतलब यहाँ जो है वो जो एनर्जी है वह कहाँ शिफ्ट हो रही है, हायर की तरफ शिफ्ट हो रही है, और ये जो एनर्जी है वो कहाँ की तरफ शिफ्ट हो रही है, लोअर एनर्जी के लिए शिफ्ट हो रही है. Yes or no? And shifting toward the higher energies. In this case, shifting towards the higher, shifting towards the higher energy. Shifting towards the higher energy. अब देखिए ये दो नेचर देख लेंगे तो आपको समझ में आ गया कि मतलब यहाँ का 1/3 यहाँ है, yes or no, और यहाँ का 1/3 यहाँ है, मतलब डेफिनेटली दिस एनर्जी इज ग्रेटर देन this one, yes or no? मतलब shifting toward the high energy, shifting toward the high energy. Here shifting toward the lower energy, shifting towards the lower energy. In which case beta minus decay. In which case beta minus decay. Beta minus decay with the energy. What is the beta minus decay? zxa. Always memorize beta minus particle out, beta plus particle is out, beta minus one charge particle is out, e to the power 0. ओके, या माइनस है तो यहाँ क्या लेना पड़ेगा, z+1 y particle a is constant, electron particle anti-particle. This one is a particle, means we can take the anti-neutron. Got it? That x is equal to this one. This is going to be beta minus decay. Okay, shifting toward the lower energy, shifting toward the higher energy. Why such thing has happened? Simple. Beta plus. Charge is a positive. Charge is a positive. Nucleus charge positive, negative. Nucleus charge positive, negative. Nucleus also charge have positive. And the beta plus have charge also positive. Yes or no? Because क्या cause इसका because of repulsion. Because of repulsion. Why repulsion will be take place? Because nucleus have positive charge. Nucleus have positive charge and positive nature. And beta plus also have positive nature. Beta plus have positive. Yes or no? Positive attraction, repulsion. Positive repulsion. Positive repulsion. Here, because of attraction. Because of attraction. Attraction किसमें होता है? Like unlike always. Nucleus positive. And here beta minus is a negative. So this is the attraction will be take place. Attraction, energy shifting toward the lower value. Here is a repulsion, energy shifting toward the high value. Okay. Now if the maximum number of beta particle having 1/3, max number of beta particle is 1/3 of maximum number of beta particle are having how much? Are having 1/3 of Emax. Having 1/3 of Emax. Then what is the remaining? Then what happened? About remaining? Then what about remaining? Then what happened about remaining? Remaining 1/3 beta के लिए गया तो वो remaining 2/3. Remaining is how much? 2/3. 2/3 Emax is remaining. Yes or no? 2/3 of Emax is remaining. Okay. Means the maximum number of beta particle are having the 1/3 of Emax. Then what happened with the remaining? Taken by which particles? Neutrino particles. Taken by neutrino particles. Got it? 1/3 for beta, 2/3 for neutrinos. Okay. Got it? This is the nature of beta plus and beta minus. Beta plus shifting to the higher value. Why? Because of here plus like repulsion. Hence here energy levels are shifting towards the higher energy. It is opposite attraction shifting toward the lower value. Got it? The maximum number of beta particle having the 1/3 of Emax. 1/3 of Emax. Then what is the remaining? 2/3 is taken to the neutrino. Beta decay problems, Skinner state questions 2013. Which of the following particle or assumed to be involved in a beta decay process in order to explain the continuous spectrum of a beta decay? Yes or no? Means which component is important for continuous spectrum of a beta decay? Why this one is continuous? Because we know that studied the neutrino particles. Yes or no? Or we can check the another options. Pion is important, no problem. This also related with the nucleus, but this one is related with in which theory? Echo theory. We know that proton is converted into neutron and neutron is converted into proton. At that time, pion is important particle. Okay, but this is a Yukawa. Means pion is not a correct option. Next, Muon is related with the leptons. This is also not a correct option. And we know that Higgs boson is not related with the beta. So, means which of the following one option is the correct one? A neutrino is important. Yes or no? Because here the setting of energy with a beta in beta particle with a neutrino particle. Yes or no? Means here which option is correct one? Neutrino gives the continuous energy spectrum in beta decay. Okay, which of the following violates by beta decay phenomena? Energy conservation, yes. Okay, energy conservation and spin conservation. We know that in beta decay is not conserved. Initial one before Paul is not invented. Neutrino, yes or no? This one is correct option. When pion is neutron is not invented. At that time, conservation of energy, or we can take the conservation of spin, is not conserved at that time. But now neutron is invented. Yes or no? Means energy conservation. Energy conservation is possible. Okay. हमने तो देखा है 5 mega electron volt can be distributed with a beta particle with a neutrino. Suppose beta particle attain the 3 mega electron volt, then a neutron attain the 2 mega electron volt. Means energy conservation is possible. Okay. They ask which of the following is not violated in this case. तो conservation violate नहीं हो सकता. Yes or no? Is the momentum also not violated in this case? Angular momentum, already we can study the spin momentum is conserved. Okay, means these two quantity also conserved in beta decay, except parity violation. Parity not conservation. Parity is not conserved. Always memorize in beta decay parity violates because of neutrino natures, velocity of neutrino. Parity violates in beta decay because of parity violates in beta decay because helicity of neutrino, because helicity of neutrino. Always memorize this sentence. Parity violates in beta decay because of helicity of neutrino. Remaining all components are conserved. All components are conserved in beta decay. अभी हम देखेंगे बीटा डिके सिलेक्शन रूल. बीटा डिके सिलेक्शन रूल. ओके, बीटा डिके सिलेक्शन रूल. Okay, beta decay selection rule. Okay, now this one is a which type of interaction? This is a weak interaction. Weak interaction. Weak interaction. Weak interaction. Weak interaction. Okay. We know that in beta decay, X particle decay into Y. Yes or no? X particle decay into Y particles with emitting beta. Yes or no? Beta may be positive, negative. Okay. Beta. Now we can find the like a spin parity. Yes, Ji phi I is equal to, this one is the initial one, is equal to yes, JF phi F. This is for initial one, this is for final atom. Spin parity for initial atom, spin parity for final atoms. Okay. Next, we know that J bar is equal to total angular momentum. J bar is equal to L bar plus S bar, L bar plus ES bar. Okay. Now we can take the total J, delta J. Next we can take the delta J is equal to how much? Then here we can take the delta RHS also. We need to take the delta L bar plus delta S. Delta L bar plus delta. Now, what is the condition is important here? Delta L is equal to 0. Delta L is equal to 0 is always for beta decay. Always for beta decay. For even or odd. Always for delta L is equal to how much? 0, or always for beta decay even odd. Next, delta L is equal to 0. We know that delta J is equal to how much? Delta J is equal to delta L plus delta S. So no, total is equal to L plus S. Now, here is the two types of transition. One is a Fermi transition, and the second one is GT transition. Fermi transition. Fermi transition. And the second one is the GT, Gamow-Taylor. Gamow-Taylor transition. Okay. FT transition and GT transition. Directly short form FT and GT transition. This is a very simple question. Asking for a site, a gate, and a net also. Because you memorize this rule, within a second we are getting the answer. See here, Fermi energy is equal to this one. बट ये डिफिकल्ट भी क्वेश्चन है. कब तक ये डिफिकल्ट है समझ लीजिए. अब तक आपने ये रूल्स पढ़े ही नहीं है. अब तक ये रूल्स आपने पढ़े ही नहीं है. What is this first rule here? Fermi transition and second one is the Gamow-Taylor transition. Okay. अब तक मेरे हिसाब से तो मैक्सिमम स्टूडेंट ने पहली बार वो छोड़ ही दिया वो क्वेश्चन. आप देखा नहीं अब तक तो आप देखेंगे यार ये क्वेश्चन तो बहुत डिफिकल्ट है. ये तो अब कैसे सॉल्व करना है ये तो आपके दिमाग में नहीं आता है क्योंकि ये तो जनरली आप स्टडी ही नहीं करते हैं. समझ में आ गया Gamow-Taylor ट्रांजिशन और फॉर एफटी ट्रांजिशन. अब तक आपके लिए ये तो डिफिकल्टी है. अभी ये जो प्रॉब्लम है आप साइड में देखेंगे सिर्फ क्वेश्चन पेपर सॉल्व करते देखेंगे तो यार वो तो छोड़ ही देंगे. मैं कॉन्फिडेंसली आपको बोल देता हूँ कि आप ये छोड़ ही देंगे. लेकिन आप एक बार वो पढ़ लेंगे ना तो आप कभी भी वो क्वेश्चन छोड़ेंगे ही नहीं. पहले वो देखेंगे क्वेश्चन यार कहाँ आ गए वो क्वेश्चन. ये देखिए 1 मिनट में वो सॉल्व करेंगे 2 मार्क्स आपको मिल जाएंगे सेट में. कॉन्फिडेंसली आई विल टेल यू. ओके एक बार आपने ये रूल कर दिया ना 2 मार्क्स आपके फिक्स हो गए. चलो कैसे देखिए फर्मी ट्रांजिशन. फर्मी ट्रांजिशन फॉर फर्मी केस डेल्टा S is equal to 0. Delta S is equal to 0. Already delta L is equal to 0. Then delta J is nothing but delta S. Okay. Now write down here. Don't take here delta L. Directly write down the delta L is equal to delta S. Delta L is equal to delta J is equal to delta S. Because in a beta decay delta L is equal to 0. Then delta J is equal to simply delta S. For Fermi transition delta S 0. Delta S 0 means delta J also 0. Only means we need to say this difference is equal to 0 FT transition. Difference is 0 FT transition. Next here delta S is equal to 1. Delta S is equal to how much? 1. Delta S is equal to 1. Then this transition is known as delta S is equal to 1. Then delta J also 1. Delta J is equal to 1. Then we can say this is known as a GT transition. This is known as a which transition? GT transition. Okay. What is the selection rule for GT and FT? GT and FT. GT transition. GT transition as delta S is equal to 1. Then delta J also is equal to how much? 1. Delta J also is equal to how much? 1. Okay. Now this one is a beta decay selection rule. Now X compound X particle is decay into Y particles with emitting beta. Okay. What is the spin parity for X particle? J I pi I. What is the final parity? J for pi. And we know that general J bar is equal to L bar plus L bar. Then delta J is equal to delta L plus delta S. But for always for beta decay, delta L is equal to 0. Then delta J is equal to simply delta S. Okay. Then what is the value of delta S for FT transition and GT transition? FT, Fermi, GT, Gamow-Taylor. For Fermi transition, delta S 0. Delta S 0 means delta J also 0. Delta J also 0. Next, Gamow-Taylor. Delta S is equal to 1 means delta J is also 1. Second, here S value 0. Here S value 0. Here this one is a positron antiparticle. Spin is -1/2. Spin is -1/2. Neutron is a particle. Is a +1/2. Neutron is particle 1/2. Means here S value minus 1 by 2 plus 1 by 2 plus 0 means RHS 0, 0 minus 0. Delta S is equal to 0 for this reaction. 0 for this reaction means this is type of interaction is FT transition. FT transition. Why we can say this is FT? Because here delta S is equal to 0 implies that the delta J is equal to also 0. Yes or no? And delta L is equal to 0 means parity is even. Okay. Next 3H1, 2S3, S 0, 0. Electron spin 1 by 2. Neutrino spin minus 1 by 2. Spin minus 1 by 2. Okay. Means here delta S is equal to 0. Delta S is equal to 0 implies that delta J also 0. Type of transition, Fermi transition. Type of transition is how much? Which one? Fermi transition. Yes or no? This one is FT transition, FT transition and ZT transition. 2He6 B minus 3Li 6 3Li 6 is equal to J pi is equal to 0 plus and J pi is equal to 1 plus. Okay. एक क्वेश्चन सॉल्व करते सिंपल सा ख्याल में रखना क्या रखने का है डेल्टा एस इज इक्वल टू 0 डेल्टा जे इज इक्वल टू 0 तो डेल्टा एस को डोंट वरी मैंने दो एग्जांपल आपको डेल्टा एस ऐसे ही दे दिए थे ठीक है लेकिन इतने तो सेट में डिफिकल्ट क्वेश्चन नहीं आएंगे जनरली लेकिन आपको डेल्टा जे चेक करने के लिए तो डेफिनेटली आ सकता है इसके कोई कंफ्यूजन होने का चांस ही नहीं है सिंपल से जे पाई इज इक्वल टू हाउ मच 0 प्लस एंड जे पाई इज इक्वल टू हाउ मच 1 प्लस अभी इसमें करना क्या है सिंपली डेल्टा जे से करना है क्या करना है मुझे डेल्टा जे से करना है भाई मेरा डेल्टा जे इक्वल टू 0 आया तो इसका मतलब ये एफटी ट्रांजिशन है और डेल्टा जे इक्वल टू मेरा प्लस आ रहा इसका मतलब ये मेरा जीटी ट्रांजिशन है इसमें आपको कुछ नहीं फाइंड आउट करना आपको इसके कॉन्फ़िगरेशन लिखने का नहीं है जे लिखने का नहीं है डेल्टा एल लिखने का कुछ भी करने का नहीं ओनली फोकस ऑन जे पाई जे तो डेल्टा जे इज इक्वल टू 0 और डेल्टा जे इज इक्वल टू 1 डिफरेंस इज 1 गॉट इट समझ लीजिए ये मेरा 0 प्लस है ये 1 प्लस ऑलवेज मेमोराइज सेकंड थिंग आल्सो पैरिटी मस्ट बी सेम पैरिटी चेंज नहीं होनी चाहिए अलाउड ट्रांजिशन में किसमें अलाउड ट्रांजिशन बोथ आर एफटी एंड जीटी आर अलाउड ट्रांजिशन आल्सो इंपॉर्टेंट दिस वन इज अलाउड वन ओके दिस इज अलाउड ट्रांजिशन दिस वन इज अलाउड ट्रांजिशन ओके 2He6 to 3Li7 they are given all this data इसमें आपको पूरा डाटा दिया जाएगा बस फोकस ऑन जे आई पाई यानी जे पाई व्हाट इज द डिफरेंस हियर डेल्टा जे इज इक्वल टू 1 minus 0 1 minus 0 1 1 minus 0 difference is a plus 1 difference is 1 we can say this is a type of transition is a gamotelar transition is gamotelar and allowed this also important okay gametelar and this one is allowed sometimes they ask this one is allowed or not allowed this one is allowed no problem because they are satisfy the selection rule second one CO2 CO60 J pi 5 pi to 4 pi means here delta J is equal to yes 5 minus 4 is a plus 1 5 minus 4 is plus 1 means this again difference delta G is equal to plus 1 type of interaction gamotelar transition and allowed all question they are don't ask allowed or not allowed but sometimes they are given only this is a ZT transition or FT transition okay next O14 J pi 0 pi is equal to and 14 yes here delta J is equal to 0 minus 0 difference is 0 type of interaction is the FT transition FT or Fermi transition got it this is known as a Fermi transition is a very simple delta J is equal to 0 the difference is 0 FT transition difference is a plus 1 difference is 1 ZT transition type of transition is a ZT transition delta J is equal to 1 ZT delta S is equal to 0 FT now next the first forbidden transition for the transition First forbidden case. Here is the first forbidden. Initial one, both are allowed. Both transition are allowed. Okay. In allowed case, when that j bar is equal to L bar plus L S bar and delta j is equal to S bar, because in this case delta L bar is equal to how much? 0 only. Okay. And delta S is equal to 0. Type of transition is a Fermi transition. And delta S is equal to 1. FT transition. Yes or no? Or GT transition. GT transition, delta S is equal to 1. FT transition, delta S is equal to 0. This one is a Fermi and GT are allowed. Fermi and GT are allowed. Here is a forbidden. Which type? Forbidden type. But which one? First forbidden. First forbidden for this transition. LB is equal to 0 and parity is changed. Parity is a change. This is a very, very important. Parity is a change. Last case, parity does not change. In allowed case, here parity is changed. Fermi selection. Delta J is equal to 0, plus or minus 1. 0, plus or minus 1. This is for first forbidden case. Delta is equal to 0. Which case? Fermi transition, no problem. But in which case? Allowed case. Here also delta J is equal to 0. We can say this is also first forbidden, allowed case. Yes or no? Because in the last case, previous case, allowed case, also delta J is equal to 0. Here also delta J is equal to 0. Then what is the difference between them? Here main difference is that in the last case, parity does not change. But here, parity change. This is the best difference between first forbidden and allowed FT transition. Got it? This is the small difference in allowed Fermi transition and forbidden FT transition. Got it? Selection rule for Fermi selection, 0, plus or minus 1. 0, plus or minus 0 we can say in allowed also, in forbidden also delta J is equal to 0. But what is the difference here? Only parity change. Last case parity does not change. Here parity always change. Okay. Next. Except 0 to 0 transition. 0 to 0 transition is not allowed in which case? First forbidden case. 0 to 0 transition is allowed in allowed case. Yes or no? FT mother 0 plus FT transition. Okay. But first forbidden 0 to 0 transition is not allowed. Okay. Got it? Parity, suppose some example is like that. They are given suppose 0 plus and 0 minus. 0 plus and 0 minus. Yes or no? What is the difference here? Difference is equal to 0. Then we can say this one is FT transition. Yes or no? Why? Because delta J is equal to 0. Yes, no problem. Delta is equal to 0 is satisfying. Okay. But here is parity is a change. Parity change means this one is a first forbidden case. In first forbidden case, 0 to 0 is not allowed. Okay. Means this one is not allowed in both cases. FT as well as first forbidden of FT also. But here both plus. Parity does not change. Delta J is equal to 0. Then we can say this one is a Fermi transition and allowed. FT transition and allowed. Got it? Next. Second one. And gamma Taylor. 0 to 0 is not allowed. 0 to 0 is not allowed. 1 by 2 to 1 by 2 also not allowed. 1 by 2 to 1 by 2 also not allowed. And third is a very important. 0 to 1 or 1 to 0. Here is a both direction arrow. Okay. Means 0 to 1 is not allowed. 1 to 0 also not allowed. Got it? This is the restriction. In which case, GT rule. Delta J is equal to 0, plus or minus 1, plus or minus 2. But except these three things. Okay, next one. Delta J is equal to 0. Delta J is equal to 0. Here also 0, here also 0. Here also 0, here also 0. But in FT, first forbidden Fermi transition, this one is a not allowed case. Means suppose parity is a change. Suppose it's like that. 0 to 0 plus. 0 plus 2, 0 minus, suppose 0 plus 2, 0 minus. Then what is the delta J difference? Delta J difference is equal to 0. Yes or no? Then we can say this one is FT transition. Yes or no? Yes. We can say like that. Here parity change means this one is a first forbidden. This one is a first forbidden because here parity is a change. Okay. Next one. Delta J is equal to 0. Here also 0. Here also 0. But FT is not allowed. Why? Because 0 to 0 is not allowed. In this case, except 0 to 0 means both cases this one is a not allowed one. Okay, now means for ft and gt both cases this one is a not allowed one. Okay, next 0 to 1 or 1 to 0 means suppose here is a 0 plus and here is a 1 plus, 0 plus and 1 plus. What is the difference? Delta j is equal to plus 1. Delta j is equal to plus 1. The type of transition is a GT transition, no problem. But this one is not a first forbidden transition. Why? Because this one is not a first forbidden, because here parity is a plus, here also parity is equal to plus. Okay, means in both cases parity is the same, means GT transition and allowed. This one is not a forbidden transition. Next, here is a suppose 0 plus and 1 plus, sorry, 0 plus 1 minus or 1 minus 0 plus, 1 minus 0 plus. Here parity change means first forbidden case, 0 minus 1, 1, 1 0 also take positive only, don't take negative. Means here also difference is plus 1, here also difference is plus 1. Means we can say here also difference plus 1, here also plus 1, difference is allowed. Yes or no? But second case, here 0 to 1 or 1 to 0 is not allowed in FT transition. Means in FT case, this one is not allowed. FT case, this one is not allowed. Next, focus on FT. GT is not allowed in this case, because GT case 0 to 1, 1 to 0 is not allowed. For GT transition, this thing is not allowed. Next, focus on FT transition. FT 0 to 1 or 1 to 0, no any restrictions. Means we can take this difference is equal to how much? This difference is equal to plus 1 FT transition. This difference is equal to plus 1 FT transition. But here is a both parity does not change. This one is a GT transition. Got it? Here parity change. Hence this one is the first forbidden FT transition. Here is the parity does not change. Means this one is a GT transition. Got it? Next, focus on 3. Here, parity does not change. Yes, parity change. First forbidden. Parity change. First forbidden. Next, check the delta j values. Delta j value is equal to 0. Delta j value is equal to plus or minus 1. Then type of selection rule is Fermi. Okay. Here also 0, plus or minus 1. Here also 0, plus minus 1. And both cases parity will be changed. Yes or no? Means here we are getting support difference is equal to 0. Yes, this is a FT transition as well as GT transition. Means in this case, this is a mixed one. FT as well as GT. Okay. Similarly, here also we are getting suppose plus 1 minus 1. Here also both are mixed. FT as well as GT. Don't confuse in this case. Means here difference getting 0, plus or minus 1, 0, plus or minus 1, and parity change. We can say this is a FT transition as well as GT. Both are allowed. Okay. Now see here 7 by 2 minus 5 3 by 2. 7 by 2. The parity change means first forbidden. 7 by 2 minus 3 by 2. 7 minus 3 4. 4 by 2. 7 minus 4 by 7 minus 2 7 by 2 minus 3 by 2 is equal to how much? 4 by 2. Means this is equal to how much? 2. Means delta j is equal to how much? 2. Delta j is equal to 2. Difference 2 plus 2 or minus 2. Transition, type of transition is first forbidden GT transition. Or we can say that this one is a GT transition. Got it? Next, 0 to 1, delta j. Delta j is equal to how much? Plus 1. Delta j is equal to plus 1. But 0 to plus 1, 0 to minus, 0 to 1 to 0 is not allowed in GT transition. Hence, this is only simply FT transition. Got it? Next, 2 minus 2 plus. Here, parity change. First forbidden. 2 minus 2, 0. Means delta j is equal to 0. In both cases. Okay. FT as well as GT. Okay. Parity change means this one is the first forbidden. Means here FT plus GT. Both are mixed one. FT as well as GT. Next. Here 7 by 2 plus into 7 to 7 by 2 minus. Means here difference is delta j is equal to 0. Here difference is 0. No problem. Difference is 0. We are getting ft transition as well as gt transition, because here 0 to 0 is not transition. Here other difference is a 0. Yes or no? Means here also ft plus gt is mixed. ft plus gt is mixed one. Okay, ft plus gt is mixed. Next, 7 by 2. Difference delta j 0. Delta j is equal to 0. ft plus gt. ft plus gt. Got it? Next, this example 7 by 2 minus 7 by 2 minus. Next example is 55 137. 55 137. 7 by 2 11 by 2 plus 7 by 2 plus 11 by 2 minus 7 by 2 minus 11 by 2. Okay, 7 minus this is a 4. 11 by 2 minus 7 by 2 is equal to how much? 4 by 2. 4 by 2 is equal 4 by 2 is equal to how much? 2. This is equal to getting 2. 2 is only for GT transition. 2 is only for GT transition. Got it? Next, here 5 by 2 1 by 2. Parity change, first forbidden. 4 minus 1 4. 4 upon 2 4 upon 2. 5 by 2 minus 1 by 2 is equal to 4 by 2 is equal to how much? 2. Means delta j is equal to 2. GT transition, only GT transition. Okay. Next, krypton. Here 9 by 2 5 by 2. 9 by 2 minus 5 by 2 is equal to 9 minus 5 4. 4 by 2 means delta j is equal to plus 2. Type of transition is GT transition. GT transition. Got it? Proper idea for this case. Selection rule, delta j is equal to 0 comma plus minus 1, but 0 to 0 is except in ft transition. Delta j is equal to 0 comma plus or minus 1 comma plus or minus 2. This rule for GT first forbidden, but here 0 to 0 is not allowed. 1 by 2 to 1 by 2 is not allowed. 0 to 1 or 1 to 0 also not allowed. Okay, this is the selection rule for first forbidden beta decay. First forbidden beta decay for ft as well as GT transition. Second forbidden. Okay, what is the rule for second forbidden transition? Second forbidden transition, for this transition LB is equal to how much? 2 and no change in parity. No change in parity. First forbidden, we know that parity will be changed. Parity will be changed. Yes or no? LB is equal to 1 and parity is changed. Here LB is equal to 2 and parity no change. Parity no change. No change in parity. Okay. And what is the selection rule for forming? Delta j is equal to plus or minus 1 comma plus or minus 2. Plus or minus 1 comma plus or minus 2. And what is the selection rule for gamma ZT? What is the selection rule for ZT? ZT, okay. ZT is equal to plus or minus 3 comma plus or minus 2, and 0 to 2 is not allowed. 0 to 2 is not allowed. Okay. Now see here, 3 plus 2 0 plus. Delta j is equal to, yes, 3 minus 0 is equal to how much? 3. 3 belongs to ft transition, GT transition. 3 belongs to GT transition. Yes or no? Is here difference is equal to how much? 3. Difference is a 3. Then we can say this one is a second GT transition is allowed. Second forbidden GT transition is allowed. Why? Because here GT delta j is equal to how much? Plus or minus 3. Plus or minus 3. Next, 7 by 2 3 by 2. 7 by 2 3 by 2. Okay. 7 minus 3 4. 4 upon 2. 7 by 2 minus 3 by 2. Okay. Delta j 7 minus this is equal to 4 by 2. 4 by 2 means 2. Okay. Means delta j is equal to how much? 2. Delta j is equal to 2. Means in GT also delta j is equal to here also 2. And parity does not change. Parity सुद्धा change झालेली नाही या केस मध्ये. म्हणजे we can say this one is a mix ft plus GT because both rules are satisfied in this case. Okay. Next, 0 plus 2 3 plus. 0 plus 2 3 plus means delta j is equal to, suppose here is a minus 3. Delta j is equal to minus 3. Type GT transition. Got it? This is the selection rule for second forbidden GT and FT transition. Fermi transition and GT transition. Okay. Delta z is equal to plus or minus 1 comma plus or minus 2 at t plus or minus 2 comma plus or minus 3 gt, and parity does not change. Parity does not change. This is the very important thing. Now next, the summary of this all at t and zt. First one, general allowed case. General allowed case. What is the selection rule? Allowed case, delta s is equal to 0. FT transition. Delta j is equal to delta s. Always memorize in allowed transition. Delta j is equal to delta s. And suppose its transition is Fermi, then delta s is equal to 0. Delta s is equal to 0. And for GT transition, delta j is equal to 1. Delta j is equal to 1. Got it? But here always memorize. Parity does not change. Parity does not change. Because in first forbidden also, delta j is equal to 0 and plus 1 is allowed. Okay. But what is the difference in first forbidden and allowed case is only parity. Only parity. Got it? Next. First forbidden. First forbidden. What is the difference between Fermi GT transition and first one? Only parity change. Parity change. First forbidden, parity change. Selection rule. 0, plus or plus minus 1. 0, plus minus 1, plus or minus 2. Okay. What is the difference here? Only parity change. And the next one is the second forbidden case. Second forbidden case. Again, parity does not change. Parity does not change. Selection rule. Delta j is equal to plus or minus 1, plus or minus 2. 0 to 0 is not allowed in a second forbidden case. Plus 1, plus minus 1, plus minus 2 for FT transition. In this case, restriction 0 to 0 is not allowed. Next, GT plus or minus 2, plus or minus 3. In this case, 0 to 2 transition is not allowed. How to identify this one is a second forbidden or first forbidden? Check the parity. Here, plus to plus, minus 2 minus or plus to plus. Means here is the parity does not change. Minus to minus or plus to plus. Parity does not change. Second, parity change. First, parity does not change. Allowed. Allowed first and the second lecture everything. Okay, now we can see the some set problems. They ask for 2 marks. Set 2015. A state of a following decay mode in the category of allowed, forbidden and Fermi or Gamma-Teller transition. Fermi or Gamma-Teller transitions. Okay, here is the Ni64 to the copper 64. Here 0 plus, here is a 1 plus. 0 plus, 1 plus. Okay, which of the following option is correct? Fermi transition and allowed, Fermi transition and second forbidden, GT transition and allowed, GT transition and third forbidden, GT transition and third forbidden. Okay, first focus on only plus 1 and 0 plus, that's it. Don't focus anything of these things. Don't worry about that. Only focus on 0 plus and 1 plus, 0 plus and 1 plus. Okay. Now see here, 0 plus and 1 plus. We know that check the selections rules. Selection rules. So delta s is equal to 0 and parity does not change. FT transition. Delta s is equal to plus 1 and parity does not change. GT. Parity change. Parity change. First forbidden. Parity does not change again. Second forbidden. Parity does not change. But in second, starting plus or minus 2. Plus or minus 2. Both Fermi and FT. But here difference is delta j is equal to how much? 0. Delta j is equal to 0 and parity does not change. FT transition. Which transition? FT and allowed. FT transition and allowed. Where is the FT and allowed? Optional one. No need to check anything other. Why? Because here difference is equal to 0 and parity does not change. Parity does not change means we need to check allowed, Fermi and GT, allowed and second forbidden. But the second forbidden का कोई excuse होने का chance होता ही नहीं, because here delta is equal to 1. Okay, not here is the FT transition. This is a GT transition. Where is the GT? GT transition and allowed one. GT transition allowed one. Why? Because here difference is a plus 1. Difference is a plus 1. Got it? Means here is the delta J is equal to plus 1 GT transition and allowed one. and GT third का तो कोई excuse नहीं. Why? Because here difference is not equal to 3 or 2 or 3. Okay, next. Clarify the following decay mode in the category allowed, forbidden and Fermi gamut tellers. Okay, here is n14 to 14, 0 plus 0 plus 0 plus 0 plus delta j is 0, delta j 0 means this is a first forbidden or allowed one, but first forbidden का तो कोई chance नहीं है, second forbidden में delta j 0 नहीं है, तो इसमें 0 parity does not change, मतलब ये कौन सा हो गया, allowed ही केस हो गया. yes or no? 0 किस में है, allowed में है और first forbidden में है. first forbidden का चांस क्यों नहीं, because here parity will be same, parity will be same, means here 0 delta j is equal to 0, Fermi transition and allowed, Fermi transition and allowed. ये थोड़ा प्रैक्टिस होने के बाद, ये देखने के बाद आपको लग गया ये क्वेश्चन इतना है, क्वेश्चन पढ़ने से पहले वो आंसर लिख सकते हैं, क्वेश्चन पढ़ने से पहले आंसर लिख सकते हैं. yes or no? Simply see here 1 plus 2 तो 0, but don't worry about that. Here read करने की जरूरत नहीं है, direct we can take here only, focus on here, we getting the answer in a fraction of seconds. Here 0 to 0, empty and allowed. Yes or no? To 2018, in excited nucleus decayed from an energy levels having the spin and parity 3 plus to another energy levels having the spin parity of 0 plus by emitting a beta particles. The above beta decay has the prominent decay mode of yeah case which of the following mode are possible. Okay, now here transition is 3 plus to 0 plus, 3 plus to 0 plus, 3 plus to 0 plus. Parity change, parity does not change. Here parity does not change. Parity does not change means none of this option is not allowed here. Means कोई ना कोई ऑप्शन तो यहाँ आएगा ही, इसके लिए तो कोई एक्सक्यूज नहीं है. मतलब आप जो डायरेक्ट जंप कर सकते थे, none of this 3 plus to 0 plus is not allowed direct. So many candidates write down none of this option is correct one, but they are given none of this, no any one option given are none of this. Okay, means यहाँ कुछ ना कुछ आपको तो करना ही है. Okay, देखिए here parity does not change. Parity does not means the two options. Which two options? Allowed and not allowed by. Both are allowed, but what is the difference? One is allowed and the second one is second forbidden is allowed. Yes or no? Check only allowed or second forbidden is allowed. Okay, allowed delta j is equal to 1 or delta s is equal to 0, but here delta s is not equal to 0 and delta j also is not equal to 1, means ft or gt transition is not allowed. This one is not allowed. Yes or no? Second one, take the second forbidden transition. Second forbidden transition, we know that in this case delta j is equal to plus 1 comma plus or minus 2 is allowed for ft transition. Yes or no? Means ft transition is not allowed. Then check the gt transition, plus or minus 2 comma plus or minus 3. Yes or no? Means here difference getting delta j is equal to how much? 3. Delta j is equal to 3. Transition allowed. Gamma-Taylor transition, in which case second forbidden Gamma-Taylor transition is allowed. Why? Because here delta j is equal to how much? 3. This is a very complicated question in a SET exam. Yes or no? Because here they ask in a second forbidden case. Yes or no? Generally they ask directly 0 to 0, 1 to 1, 1 to 0, 0 to 1, like that. Yes or no? But so many times they ask questions same manners and they ask us slightly difficult for second forbidden.